My name is Dr. Dennis Reschke, and this is the series in dealing with the creation evolution issue. We are using the Fingerprint of God by Hugh Ross as a text, and this evening we'll continue with quantum physics as an alternative explanation to the Big Bang, and how there are loopholes in those theories. But before, and then we'll go on to the anthropic principle, and if we have time tonight, UFOs. But before that, I'd like to take a little rabbit trail and talk about the transcendence of God. We discussed last time that for a Big Bang event to occur, there would need to be a cause, and that cause would have to be outside or in a separate dimension of time than the one we find ourselves in. So God of the Bible fits that description. The very first verse of the Bible, in the beginning God created heaven and earth, suggests at least a second dimension of time which God operates in, because cause and effect presuppose time. And of all the holy books in the Bible, the Bible is the only one that describes God in a transcendent state. Now, we have to define the word transcendent. Other holy books use that term, but it's always in the sense of sort of a souped-up human being, still caught in our four dimensions, time being our fourth, but in some other state, but still in those four dimensions, whereas the Bible clearly describes God in terms of transcendence, that is, outside our time and space dimensions. And I want to go through those quickly here. The first one, God existed before and totally apart from the universe. So this is the definition I'm giving of transcendent, outside our four dimensions. Two, God created the universe out of that which cannot be detected with the five senses. Hebrews 11:3 says, "By faith we understand that the world was framed by the word of God, so that the things that are seen are not made by the things that do appear." In other words, God spoke the universe into existence out of nothing. Science has proven that matter and time started at what is called the singularity, that initial Big Bang, some 15 billion years ago. And this verse, among others, describes how that occurred. Remember, at the very beginning of the course, I mentioned that we can take advantage of science and meld it with Scripture, with the Bible, and come up with a more complete picture than if we just take one or the other alone. So science does not describe who at all, and the Scriptures describe a lot about who, but not so much about how. The Bible is not a science book, nor was it intended. So we can meld the two here and get a clearer picture. Number 3, time is the beginning. God existed and acted before this created time. 2 Timothy 1:9 and Titus 1:2 are scriptures that describe that aspect. Jesus passed, number 4, passed his physical body through walls. Now, people balk at this precisely because they look at God as some sort of souped-up human being. Now, surely human beings cannot walk through walls. And so, at the initial reading, this appears absurd. But it would only take 6 space dimensions to walk through a wall. We operate in 3. It's almost trivial. supercomputers describe up to a million space dimensions possible. God could operate in infinite or even spiritual dimensions, but the issue I want to bring up here is that God is transcendent in the sense that he operates in other dimensions than we find ourselves, yet is able to enter into our dimension. There's a mathematical theorem that says you cannot visualize phenomenon in dimensions you cannot experience. So it's hard to talk about dimensions, different dimensions. There's an illustration I think is helpful in dealing with the whole issue of dimensions. Think for a minute if we only operate in two dimensions, length and width. So as a plane, we can only see in or straight in front of us, behind us, but we cannot experience anything above and beneath. Let's just say we could only operate in two dimensions. So our whole existence would be planar, just plane. And let's just say God operated in three dimensions. So he could also operate in this plane, but he operates in width and in height also. And let's say he communicated to us by written communication, and he said, I am near you. And let's say he was a half a millimeter above your head. Well, you would never know it. But is it true that he's near you? Yes. If you operate in three dimensions. So this is a way to jog your thinking into thinking how dimensions can explain Scripture and walking through walls. Not a hard thing if you can operate in more than the three dimensions we have. Scientists say that there is a minimum of 9 space dimensions necessary to create the universe as we know it. They say 6 of them curled up into an infinite circle. I don't know what that means. Don't ask me. But very soon after the Big Bang event, they basically don't exist anymore in all practical purposes. So God must at least operate in 10 dimensions. Could be infinite, could be no dimensions, spirit dimension, who knows, but at least 10 dimensions in order to create a universe as we have it. God, number 5, God has no beginning and was not created. The scriptures are described here, listed. 6, God is very near, yet we cannot see him. And that illustration hopefully will help you see that. So the Bible is the only holy book that teaches an extra dimensional reality that is independent of the dimensions of our universe. We dismiss these models, and this is the standard Big Bang model, but this inflationary Big Bang is actually more accurate to what we observe in nature. But to explain this, I'm going to have to take a little rabbit trail and talk about scientific notation. This is a method of using very small and very large numbers in a convenient fashion. And I'm going to be using these, so I need to explain myself. And I'll be using base 10, but don't worry about that. This, if you see something like this, means you move the decimal point over from 1 2 times. So that would be, or just add that many zeros. Okay? 10 to the 6 would be 1,000,000, and so forth. And that's all you need to know about. And then if there's a negative sign, that means you move the decimal point over that many to the opposite direction. So this would be 0.01. 10 minus 43 would be that many decimal points. Okay? So that's scientific notation. That's my rabbit trail. Okay? Well, in this inflationary Big Bang model, this little jog you see occurs, this is a time axis, and this is the initial Big Bang event, at 10 to the minus 43 and 10 to the minus 34 seconds. From the initial event, you had an explosion, a normal explosion, but during this particular period, it was called a hyperinflation. Obviously very small, I mean less than a second. This is second. Very, very small time scale we're talking about. But, and then after that, it continues on in a regular fashion. So it's a slightly increased slope, if you will, and so the y-axis is expansion. And the reason for this is if it was a flat slope, the universe would be more or less homogeneous in density. That is, there wouldn't be galaxies, there would just be matter dispersed evenly throughout the whole universe. We don't see that. We see conglomerations into stars and galaxies, and then a lot of open space. And I don't understand the math anyway, I couldn't explain why that is. But the trouble with this is that science cannot look at this area experimentally. They say it would take an accelerator over a trillion miles long to achieve experimental conditions that would mimic this state of matter. Extremely high energy particles would need to bombard each other to create that condition. So if you can imagine at this point, the entire matter of the universe is down to an infinitely small particle. I don't even know what you call it. And at this point, it's about the size of a proton, which is a part of a nucleus. At this point, it's about the size of a grapefruit. And then, of course, as you go on, much larger. But so, the problem is we cannot look at this experimentally in the lab. It's impossible, they say. We don't have the technology, nor, it seems, will we. It's just physically, there's physical limits to what we can do. And so, hypotheses abound. And you can say anything, and there's nothing we can do to prove it. Unlike Einstein's relativity equations, which were eminently provable by experimentation. Here we cannot. So one can say almost anything, and we really can't prove it or disprove it, which is disquieting, to say the least. So I'm going to take a little rabbit trail. I believe God did this purposely. He created the human condition and the universe such that we were given strong evidences for his existence, but no proof. The reason, if we could prove it, if we could prove God's existence, there would be no need for faith. And it says in Ephesians 2:8, by grace are you saved through faith. And faith, by definition, is something you cannot see. Jesus said, the kingdom of God comes not by observation. And of course, science is based on observation. So I believe, and this is just my belief, that this is part of that. That God purposely created the universe such that we could get some really hard evidences, but no proof. So we're not asked to make a leap of faith, but we are asked to make a step of faith. This whole area in here and what people have said about it in regards to how the universe came into being. The first one I want to talk about is called quantum tunneling. Quantum physics is the physics of the very small, the subatomic. So atoms are the least common denominator of all matter, and if you subdivide an atom further, you come to physics called quantum mechanics. Quantum tunneling was promulgated by a man named Paul Davies in his book God and the New Physics. And in these kind of books, you want to skip the technical stuff. Probably people like you and I don't understand them anyway. But look at the philosophy. And what we'll see here in a minute is some of his philosophy isn't that good. He said, "We know that God could not create the universe because the space-time rules of general relativity proves to us that time has a beginning." We saw that with Stephen Hawking and Elrose et al. "This rules out God because God creates through cause and effect. But cause and effect need time, and time has a beginning. Therefore, God could not have created the universe." Well, the fallacy here is thinking that God is in our time dimension. And clearly he's not. What he says is true if God was in our time dimension, but he's not. And the Bible clearly states that. It happens, and this is provable with linear accelerators and experimentation, that certain subatomic particles can actually form out of nothing, seemingly violating the first law of thermodynamics, which says energy is conserved, you can't create it or destroy it. But they disappear or reabsorb back into the atom within 10 to the minus 9 seconds. So this seemingly spontaneous, well, it's not seemingly, it is. It's been proven that this certain subatomic particles can just seemingly appear out of nothing with no prior event, but then they are reabsorbed in a very short time frame. Well, Davies argues that if this is true in particle physics, in the realm of atoms, then the same could be true here, that the universe simply popped out of existence at this time point, 10 to the minus 43. And he uses analogy to this phenomenon in the atomic level. Well, the flaw there is, if you can't keep virtual particles, if you can't keep these atomic particles, then you can't keep a universe if it did pop out. In other words, using the same principle, it is reabsorbed almost immediately. So if he uses that as an analogy, then the universe would have to be reabsorbed if it did spontaneously occur. Another flaw is the possibility of getting something out of nothing from quantum mechanics is time dependent. Even this small time frame is time, albeit small. And at the initial Big Bang event, time is zero. If zero amount of time, then zero chance of happening. If an infinite amount of time, then it's certain to happen. But since we have no time here, then the chances of something happening in zero time is zero. And it's interesting, in successive books, Davies, he's been publishing over several years now, decades, and he has evolved his thinking from starting to a more Hindu kind of God to almost transcendent personal God, which we see in the Bible. So as the data is getting better, we see him, and I think that's to his credit that the data supports that. Back in the 60s, you had books, like the Tao of Physics, Zen and the Art of Motorcycle Repair, and other type books written by physicists who were looking at subatomic particles and noting that energy and matter are the same, or they switch back and forth, which is sort of what the Hindus were saying. And I think they glommed on to that type of thinking, one, because the data wasn't all that good back then, and two, it was a very popular thing in the culture at that time. But it's interesting now, as the data get better, this was an article, 98 in Newsweek, and there was another one, I think, in Time, about a month or two later, talking about science finding God. And they're talking about astrophysicists mostly. Excuse me. And going to the Christian God, the biblical God. And so I think the data is better now, describing a personal transcendent God, and shying away from the Hindu notion of God being everything. All right, well, the second, infinite chances, Richard Goth in 1982 published a paper at Caltech entitled Creation of an Open Universe by De Sitter Space, and this was in Nature, volume 295, page 304. And he's again talking about this time frame in here, the 10 to the minus 43rd second. And his math indicated that if the universe perfectly inflated, that is, I want to say Fieldman. His name escapes me. The constant of the mass of the universe. I'm going to say Fieldman. It's something like that. I'm sorry that the name escapes me. But if that number is 1, if you recall, from the matter going out from the initial singularity, if there's enough matter, and he names that, gives that a value of 1, then the universe would continue to inflate, but deaccelerate to the point where it just kind of hangs there. That's a value of 1. Over 1, it would continue. Less than 1, it would oscillate back. And what we're finding, over 1, it would oscillate back, and less than 1, it would continue. What we're finding is a constant of 0.3. So, but this was not known during the time of this article. So, but he said there would be a washing out of information at this point if that amount of matter existed. You can hypothesize anything if there's no information, but perhaps we don't know what happened before 10 to the minus 43rd second, but whatever it was rather small and hot and incapable of life. And this constant now is quite a bit less than 1, so this really isn't a viable theory. He did postulate also that if this was so, there could be an infinite number of universes, but they would be incapable of contact between one another and could not influence each other. So one still has to explain where life came from in 17 billion years in our universe, since the others don't communicate. All right. Stephen Hawking, in his book Brief History of Time, talked about quantum tunneling in reference to time, and he kind of took what we were seeing with Davies, but in relation to time. He's proposed that time spontaneously occurred. But to his credit, he concedes that his proposal is deduced on no other principle, is simply an idea, and there's no observation, no data to support this, and there's many physicists that disagree with Hawking. So one can either disprove or prove that point. 3, man as creator. This was spearheaded by John Wheeler, and this idea that he had is based on delayed choice experiments, which is based on what's called the Heisenberg uncertainty principle. What that states is that you can't know the momentum and the position of subatomic particles at the same time. Either you know one or the other, but you can't know both. But what he says that our observation creates something, creates these events. But in fact, many data support that the observer is irrelevant to these phenomena we observe in the atom. And choosing to observe the momentum rather than velocity doesn't say that we've chosen the momentum somehow by observing it. It's just a part of the phenomenon we chose to observe. Finally, the universe is becoming God. This is pretty wild. British astronomer John Barrow and American mathematician physicist Frank Tipler, in their book, The Final Anthropic Principle, talked about this, and it's pretty wild. It deals with what they call the final anthropic principle, the participatory anthropic principle. And it's the idea, it's very Hindu, that we become God at the end of the age. He writes, there's a lengthy book that you can, it's like 700 pages. You can read it on your own, but one critic wrote this about the book. What should one make of this quartet of WAP, SAP, PAP, and FAP? These are acronyms, final anthropic principle and so forth. In my not so humble opinion, I think the last principle is best called crap, the completely ridiculous anthropic principle. Not many physicists would agree with Barrow and Tipler. All right, just a summary. There are limits to quantum mechanics. Quantum mechanical limitations apply only to micro, not macro systems. This is actually a flaw in logic called the flaw of the universal, saying that if something occurs in one instance, then it must occur in all other instances. And there's no logical necessity for that. It may not. And what occurs in the subatomic world, there's absolutely no reason to think that those same phenomena occur in the macro world, in the world we live in. The physics are different. There's no law or anything really that would suggest that necessarily the quantum mechanical rules would apply to the macro world, the world of atoms, whole atoms. The observer does not give reality to the quantum entity, but rather chooses what aspect of the reality of the entity he wishes to discern. The time separation between a quantum event and its observed result is always a relatively short one. So this is the 10th line of time. The arrow of time has never been seen to reverse. Intelligence or personality is not a key factor in the observation of quantum mechanical events. And the last one I'll cover. All right. I realize there's a lot of science there, and we have one last science-type discussion called the anthropic principle that I think is very exciting, and then we're on to biblical stuff. I want to talk now about so-called anthropic principle. Anthropic coming from the Greek anthropos, or humans. We get the word anthropology. And this is, I can't emphasize this enough. This is a principle that was come up with by non-theists, physicists, cosmologists. This is not a Christian concept at all. What this is, what I'm going to go through now, is things in the universe, and then later on things about the Earth and our solar system, which scientists have observed, and they've called it anthropic principle because what we're observing seems to indicate that the universe is created for man, it's created for humans. Again, this is by non-theists. They're saying, hey, and I'm gonna give you some quotes here as we go along. Somebody's monkeying with this stuff, they're saying. There's something going on here. that's what they're observing. You know, they can't quite put their finger on it. They're calling it an anthropic principle because so many of the parameters of the universe and of the earth seem to be made for humans. And that's exactly what the Bible states. God created the whole heavens and earth, and it was for his people. All right. Actually, Carl Sagan, you may have remembered him. He's deceased now, but a popularizer of science, was on Johnny Carson several times. Billions and billions of stars. Yeah, that was his phrase. And Joseph Shklovsky in 1963 came out with a book, Intelligent Life in the Universe. And they looked at two of the parameters, which I'm going to now describe. I have 15 here. This data is probably 10 years old. I'm sure there's more parameters that have been discovered since. But what they wanted to do is, calculate the probability of finding another Earth-type planet in the universe using these two parameters. And they came up actually with, I think in our galaxy, 1 to 2 planets. Well, if there's a trillion galaxies in the universe, which there are, then potentially you have 2 trillion Earth-type planets. But as we'll see, and I'll do the math for you, given the other parameters, they only use 2. We're going to use 15 and later 19 for the Earth. We'll see that where I'm going with this is statistically it's not rational to think that the Earth just formed. The probability of an Earth-type planet forming is so small that it's really not rational to even consider, I don't think. I'll discuss statistics here after we go through it, so I'll expand on that. Let's just go through these and quickly, and then I'll discuss the implications. 1, gravitational coupling constant. Okay, these first 4 deal with the 4 known forces of the universe. The first is just how much gravity sucks. What the force is that it brings matter together. So if there's mass, you have gravity. All mass has gravity. This determines the degree to which stars can form. I need to take a little rabbit trail here, and actually I'll answer a question that I had last week during this rabbit trail. I have to talk about the natural cycle of stars. It is observed in the universe that we have arbitrarily given our sun, our star, a mass of 1. And it's observed anywhere from 100 times our sun mass, we observe, all the way to 0.1. So the range of mass of stars that we see is anywhere from 100 times ours to 1/10 of ours. So there's a 1,000-fold range of different star masses. And there's a natural cycle of stars from birth to death. Stars die. The very largest ones end up as black holes. Black holes are nasty things. They're very, very massive objects which are, the gravitation is so strong that they even attract light. So hence the term black. If you were to look at one, it would just appear black. And these are very nasty things in the universe. Actually, there's some data to support the middle of our galaxy is a black hole. Going down in mass in this direction, a lesser mass star will end up as a neutron star and eventually a supernova. And supernovas are huge explosions. The star basically explodes. And you can imagine a star 50 times our star mass exploding. I mean, incredibly massive, destructive thing. And we've actually observed these in our time, and they've been recorded in history. They only last for a few days to a few weeks that you can see them. You can actually see them. They're so bright. during the daytime, which is one theory of the Bethlehem star. It could have been a supernova. I don't know if that's true. I'm not going to discuss that. But we have observed 2 generations of these supernovae. In other words, these stars from the Big Bang event have formed, and about 2 billion years ago, the first one formed and exploded. And a star is basically burning hydrogen, as I mentioned. Well, there's a cycle to this burning. You start with hydrogen. I'm going to bring out my little atomic chart here, or element table of elements. This is an old one. They actually go up to 112 now, but hydrogen's here on the right. And the next step, as you fuse, is a fusion reaction, like a fusion bomb. Hydrogen bomb is a fusion reaction. You get helium. Hydrogen is just 1 proton, and it's got 2. And I believe the next step is carbon. And then after that, I believe, is iron, and so forth. There's a regular sequence of fuel that's burned in stars. And what happens in these supernova events, there's been 2. The last set occurred about 10 billion years ago. We're in the 3rd set now. That heavier elements are made. You started out with the Big Bang with basically hydrogen, but now we've got, at this point in our universe history, all the way up to 112, well, 92 naturally occurring. And these are necessary for life. Life can't exist just on hydrogen. And when I say life, I mean life as we observe it. I'm not going to talk about hypothetical. Actually, I will a little later on, based on silicon and boron. But our life that we observe is based on carbon, and we have never observed any other type of life. So when I say life, that's the life I'm referring to, that kind of life that we observe. You need the heavier elements. So you need this progression of generation of elements in order to get an Earth-type planet, to get a rocky planet with iron and all these other elements. So there have occurred now 2 of these supernova sets. So in other words, after 2 billion years, you had 1 set of these supernova emitting carbon and iron, not way heavy end of the periodic chart, but starting to. And then the second occurred at 10 billion, and now we're in the 3rd set. So these are necessary for life to exist. Life, as we know it, could not have existed before, at the very least, 10 billion years ago, because the heavier elements didn't occur. Okay, that's all the rabbit trail I wanted to talk about. Back to number 1. If the gravitational coupling constant, gravity, was larger, only stars of 1.4 and greater solar mass would be formed. If smaller, then only 0.8 masses would be formed. Well, it turns out that large stars are not stable. They burn very hot erratically. They would not be capable of life. We have a small star, and it burns fairly evenly. So if this gravitational constant was different, we wouldn't have the distribution of stars that we have. And in fact, we wouldn't get, if it was smaller or larger, we wouldn't get the sun-type star. Okay. Number 2, strong nuclear force. This governs how the nucleus, parts of the nucleus stick together. If smaller, only hydrogen in the universe, there'd be no life. If stronger, everything would stick together and there would be no hydrogen. We need hydrogen for life. So if this was stronger or weaker, life would not exist. The quark theory says that if this is off by more than plus or minus 2%, life would be impossible at any time in the history of the universe. So as I'm going through these, the reason I'm going through this is physicists have looked at matter, looked at the universe, looked at the parameters, what they call the anthropic principle, and seen that if they differ at all, if they're larger or smaller, that life couldn't exist. Weak nuclear force, deals with radioactivity, atoms forming other atoms by emission of particles and or energy. If larger, all hydrogen would be converted to helium, and stars forms heavy elements but no lighter elements. And if smaller, helium would form, and none of the heavy elements would form. Electromagnetic coupling, this is dealing with chemistry actually, how atoms can bind to one another in covalent bonds. If it's stronger, electrons can't be shared, and if too strong or if too weak, they would remain as atoms and they couldn't form compounds. For instance, salt, sodium chloride is sodium atom and chloride atom combined electrically. That couldn't happen if this constant was any different. Okay, quickly, ratio of electron to proton mass. If larger or smaller, no chemical bonding could occur. The expansion rate of the universe, this is very, very sensitive. If it's too quick, galaxies can't form because gravity can't condense mass. And if too weak, a galaxy can't form, and if too small, star formation is impossible. This Robert Dickey calculated that if this changed by more than 1 to the 10 to the 55th, life would be impossible. That's an extremely large number, or in probability, extremely small. Another scientist likened it to the probability of 10,000 sharpened pencils standing on a tabletop and not falling. In other words, it's not going to happen. 7, entropy level. Entropy is kind of a weird concept. It has to do with energy that can't be used for work. Any reaction requires energy. And there's always a certain emission of energy as a result of a chemical or any kind of reaction, an emission of energy that cannot be used. And that's termed entropy. It has to do with how organized things are. There's many ways to describe it. If increased, the tendency would be to disorder and galaxies wouldn't form. And there'd be a fragmentation problem. If too small, stars wouldn't form. Mass of the universe is a density. If more dense means how much mass per unit volume. If larger, there'd be too much deuterium, which is hydrogen with one more neutron, forming at the initial creation event, and which is a catalyst for the second generation of stars. So these would burn too rapidly. If too small, not enough helium would form in the first 4 minutes after the Big Bang event. This is amazing. God had to create an entire universe for an Earth to exist. So we're talking about the mass of the universe. There's 10 to the 12th galaxies in the universe, and each galaxy has about the same amount of stars. Incredible amount of mass. And all that was necessary for an Earth-type planet to exist. If there wasn't enough mass in the universe, life could not exist. That to me speaks of the love of God. A whole universe had to be created for an Earth-type planet to form. Okay. Age of the universe. If older, if older, no solar-type stars in the right region of the galaxy, and I'll talk about what the right region of the galaxy is. And if too young, solar-type stars are not yet formed. So, as I said earlier, before 10 billion years from the initial Big Bang event, you didn't have stars whose composition was made up of the heavier elements, which are necessary for life. And if you get too far along, for instance, our sun, several billion years from now, will turn into a red giant. It will become so large and so hot, it will engulf us, engulf our planet. And its burning comes too erratic. So there's a just right period where the sun is burning evenly enough that life can exist. Uniform in the universe, uniformity. If it's too uniform, you don't get galaxies. If it's too clumpy, you get black holes. 11, average distance between the stars. It's about 40 trillion miles in real miles. If you were to put a star as a grapefruit, it'd be about 4,000 miles away from each grapefruit. That helps. If closer, gravity would disturb orbits of planets revolving around them. So if we had a star that was really close to us, our solar system, that would disrupt our orbiting. It would be disruptive. It would create us to wobble. That would not be good. And if it's too far apart, you don't get the ashes of dead stars to form the new stars, to create the next generation of stars. 12, solar luminosity. This is amazing. This has to do with how much the sun emits energy on us. Light energy, heat, all types of energy. It's grouped under luminosity. The first billion years, it's very erratic. Our sun was very erratic, as all suns of our size are. And then it reaches a steady, stable state over the next 10 billion years or so. But it increases slightly. In our history, 4.5 billion years, it's become more luminous than it was back then. That's bad. But what's amazing is, now I'm going to have to take a little rabbit trail and talk about greenhouse effect. You may have heard about it with the ozone layer destroying and an ice age. It actually wouldn't take very much temperature difference to create an ice age. About 5 degrees mean temperature decrease would create an ice age. So we're talking not much. That's why scientists are so concerned about tenth of a degree difference. You say, well, it's a big deal. It is a big deal. It only would take 5 degrees to create an ice age. And the other extreme is a greenhouse, is what we're seeming to experience now. And this has to do with the amount of CO2 in the atmosphere. As infrared light, which is heat, comes from the sun, if there's CO2 keeps it in. Some of it's emitted back out, but carbon dioxide will keep it in. If there's too much CO2, it keeps too much heat in and we get too hot. It becomes tropical here. And it sounds kind of good sometimes if you're in Montana, but for a higher life form, it's not good. And what happened is, as the sun changed its luminosity and animals and plants came to the fore, they soaked up that CO2 which was there prior, and the whole thing balanced. It counterbalanced the change in luminosity of the sun, which is amazing to me how God arranged that. So if it's too soon, you have a runaway greenhouse effect, and it's too late, you get a frozen tundra. 13, fine structure constant. This, I don't really understand this, but it has to do with Planck's constant, the velocity of light, and electron charge. If it's larger, no stars will form over 0.7 solar mass. If smaller, no stars less than 1.8 solar mass. People, Christians, have talked about the speed of light changing, and these are the so-called young earthers, those Christian scientists and people, apologists who adhere to the idea that the Earth has been around for about 10,000 years, give or take. And one of the arguments they use is that the speed of light is decreasing exponentially. And what they base that on is the fact that we've been taking observations of the speed of light for about, I don't know, 150 years now. And our technology obviously wasn't as good then as it is now. And it just so happened that their data points suggested a higher speed of light than was actually true to life. And so if you made a curve from that time, like 1800s or so, till present, it would be decreasing. And that's true if you took those data points. But all our physics equations, which have been proven time and time again, demand a constant speed of light, and this is one of them. If the speed of light changed, then this fine structure constant would change and there would be no life possible. So, to me, this is one example of what I think is a very unfair and biased approach that Christians have to this, where they purposely, and I'm sure they're aware of this, I think they are, they purposely take data that supports their thesis, but knowing that it doesn't represent reality. In any data set, this is just how science works, there's a bell curve of data. And what a lot of the young earthers will do will take points here and here to try to refute, ignoring the huge amount of data that are in the middle. To me, that's not fair. That's dishonest. To be honest with you. All right. Number 14, carbon 12 to oxygen 16 nuclear energy level ratio. If larger, sufficient oxygen. If smaller, insufficient carbon. And need these for proteins, for life. Sir Fred Hoyle, looking at this, made the comment, and he is an English cosmologist still living and rabidly anti-Christian. He says, a super intellect must have monkeyed with the physics as well as with the chemistry and biology. It's amazing. 15, the decay rate of protons. Protons are subparticles of the nucleus of an atom, and they do decay. And they have to decay. And this is really wild, I know, but I heard this on Stardate the other day. It's a radio program. And it says, the early universe calculated to be 10 billion and 1 particles to 10 billion antiparticles. 1 particle was left, and that is what our universe is made out of. I don't really understand that, but it has to do with the decay rate of protons. If too slow, insufficient matter in the universe, and if too large, then we couldn't handle that amount of radiation. All right. George Greenstein from Caltech, in his book, The Symbiotic Universe, Life and Mind in the Cosmos, writes about the coincidence in the universe. As we survey all the evidence, the thought instantly arises. This is a non-Christian, this is a non-theist. Instantly arises that some supernatural agency, or rather agency, capital A, must be involved. Is it possible that suddenly, without intending to, we have stumbled upon scientific proof in the existence of a supreme being? Was it God who stepped in and so providentially crafted the cosmos for our benefit? Now, he doesn't adopt the biblical God. He goes more to the Hindu, but based on misconceptions of quantum mechanics. Paul Davies, in his book, The Cosmic Blueprint, says that these measurements portray a fine-tuning of the cosmos. And John Barrow and Frank Tipler discuss this in their Anthropic Cosmological Principle, their book. That's that thick 700-page book. All right, one last thing, and then next week we'll pick up on Earth design and then UFOs. Geophysicists picked up on this idea about the anthropic principle and asked if there could be other forms of life possible based on different chemistry, silicon, boron. And actually, silicon is very abundant, even more so than carbon. And there are clay model theories out there, but one can only get proteins to about 100 amino acids in length. And this is not complex enough for life. Proteins are the most complex things probably in life that carry information. And there needs to be a certain minimum amount of information. We have proteins that are several hundred amino acids long, and they seem to be necessary for life. And so that's the limitation of a possible silicon-based life. Boron is the other one, and there's not a lot of research done on it. The problem with it is very scarce in the universe, so it's not likely that there's other life that's based on boron. So, with that, I think I'll quit. Next week we'll talk about the anthropic principle as it relates to Earth, and look at the probabilities of that, and then go on to UFOs. So thank you very much. See you next week.